Morning. I'm going to take you back down to Tasmania. We had a talk yesterday with Sean Westbrook, and he's predominantly working in West Tasmania, whereas I'm in Northeast Tasmania. So this is Fling Gold. Yeah, I'm an optimistic guy, so be careful. Yeah, we'll flip through some of this. So we're listed on the ASX. We've got about $3 million in cash to fund our near future exploration programs, and an experienced board of directors. We've got tenements in Western Australia with lithium and gold interests, and our main projects are in Tasmania. West Tasmania, we've got Fire Tower and Henty, which are polymetallics, zinc, lead and silver in Henty, and gold, cobalt and tungsten at Fire Tower. In the Northeast Tasmania, which is what I'll be talking about today, mainly, well, we're focused on gold, right? But there is some tin, there's some tin interest there as well. All right, so just a very, very simple intro into Tassie geology. There's basically two domains. The eastern domain's much younger. It's like Ordovician Silurian turbidites, intruded by Devonian granites. And the western side, the western half, which is, here's my other thing. So that's this part here. Oops. Anyways. Sorry. If I can get this going. There we go. Yeah, so the eastern part here and the western part. Western part's much older, it's much more structurally complex, and it's Tyanean dominantly, which is Delmarian in age and older. The two domains are separated by a structural scale fault system called the Tamar fracture zone, and it's quite obvious in the geophysics when you know where to look for it. Oops. So you can kind of see in the satellite image how the northeast part kind of just squashes on to the west part, and I kind of think of it as a little koala riding on its mother's back. Got a few laughs. So we'll zoom into the baby koala. So yeah, the Paleozoic successions are the Ordovician Silurian sediments of the Methinus supergroup, which is on the right, the purple stuff. And that's what we're interested in, that and the Devonian granitoids. On the left, there's a total. I haven't taken off any layers, and you can see there's some late Carboniferous to Triassic glacial sediments that overlie that, and they've been intruded by Jurassic dolerites, which mostly eroded now, but they create the nice topography you see in the Tasmanian landscape. And also host some ski fields there in Ben Lomond, which is this part here. It's quite high. Yeah, so why do we explore in northeast Tasmania? It's because the rocks are very similar to the Lachlan Fold Belt in Victoria. And then, we obviously like to draw similarities with the Victorian goldfields, but historically there has been a lot less production, but there's still been some significant mines there, such as the Beaconsfield mine, which has almost got to 2 million ounces, 850,000 ounces in its historic period, and then again in the modern times, which finished it in 2012, around 920,000 ounces at high grade, 10.5 grams a tonne. Another historic mine which is quite significant is the new Golden Gate mine in Methina that produced around 250,000 ounces, and the old miners, they like to mine around the 26 gram a tonne mark, so they didn't really go for anything lower than that, so that's very high grade. So where does, with all Ross Cayley's talk yesterday, where does northeast Tasmania kind of fit into the into the Tasmanides. So there's been a few theories. Mr. Berlin in 2005 suggested that it was part of the Melbourne zone, which suits our thinking, or it suits what we'd like it to be, right? Because Melbourne and Western Lachlan Fold Belt, because that's a nice history of gold production. And what he was looking at was argon dating of the orogenic gold deposits, and he found that they matched that Western Lachlan Fold Belt age. And then he draws a few similarities in the geology, or the rocks, and proposed that northeast Tasmania was underlain by like a attenuated thin slice or stretched slice of Proterozoic crust. And that kind of explains the less endowment that has been proven, and the slight variations in structural and tectonic timing, and difference in formation. There was a paper by Reed who thought it was more related to the Tabrabaran zone, and he identified a earlier deformation event in the western part of the Methinacid, so kind of the western part of northeast Tasmania. He identified recumbent folding that wasn't present in the eastern side of the sediments, and he proposed that this is Benambran in age, and therefore northeast Tasmania was affected by the Benambran origin, and it's more closely associated with the Tabrabaran origin in Victoria, or Tabrabaran zone, because that was primarily affected by the Benambran origin. And this was also agreed with some later work from the structural geophysics group at Monash University, with David Moore and Peter Betts and Mike Hall. They used geophysics to constrain, or more so divide the Vandyland continent or microcontinent into lithotectonic terrains, and they found that the eastern edge of the Vandyland continent was like it's the Governor Fault in Victoria, separates Melbourne from Tabrabaran, and in Tassie it was like identified as a Tamar fracture zone, which kind of you draw the line and link the two up. But how does this fit in with the Lachlan-Orocline hypothesis? It fits well, actually, because Moore went on to explain that there's quite an interesting, distinct spatial relationship with the age of Devonian granites in Tassie. They have a clockwise younging direction, starting from Flinders Island, which they're older up here in the top right, and clockwise around to King Island, where they're around 350 million years old for that date. And that kind of matches what would happen if you had a southwards retreating subduction system. You'd get intrusive ages becoming younger as the system goes south. But it's not really consistent with Victorian age Devonian granites, or the data that presented here anyway, which they're pretty much younger than northeast Tasmania, so still a bit of work to do there. But there is a younging from east to west in Victoria as well, despite a few anomalies along the eastern edge of the Vandyland. So gold in northeast Tasmania, you look at that map and it looks quite riddled with gold occurrences. There's around 600 recorded on the Minerals Resource Tasmania database, and it was first discovered in the 1850s with mostly alluvial mining, and there was one big field which is in the centre here. Just there. Can't point to it. Where's my laser pointer? Here it is. Here, this is Lyle, and that produced around 250,000 ounces of alluvials. And as stated before, I mentioned the Beaconsfield mine, which is here on the western side of northeast Tasmania, and then the new Golden Gate mine, which I mentioned earlier, is in the guts here, a part of this long anomalous gold corridor, which is known as the Lyndhurst-Mangana gold corridor. So, So there's predominantly two types of mineralisation. There's intrusive-related gold, which occurs obviously around intrusions, and the longer and the more structurally continuous corridors, they're more thought of as an orogenic type system. So you can see here that the Lyndhurst-Mangana corridor is around 80 kilometres long, so that's kind of a structural scale anomaly. One thing to point out is that besides those two mines that I mentioned, Golden Gate in Mathina, which went down to 500 metres, and the Beaconsfield mine went down to around 1,400 metres, right? So that's deep. A lot of, or most of the historic mines, historic hard rock mines, most of these dots where they're not alluvials, they only go down to like fresh rock, 60, 100 metres. So they kind of quit when they hit the oxide zone, and that was it for them. The reason why Golden Gate at Mathina went a little bit lower or deeper is because they actually had a cyanide plant back in the day and were able to treat the ore that was coming out. So this map shows how underexplored northeast Tasmania is, considering that a lot of these deposits haven't been explored beneath 60 metres or 100 metres. So it shows the white dots, drill holes recorded on the Minerals Resources database between 100 and 200 metres deep. So that's really testing, what is it, if you put the angle on, it's like deepest 170 metres. And red dots show greater than 250 metres. So you can see that there is a few, but really, with the amount of gold occurrences in northeast Tasmania, there's a lot of opportunity there. So our portfolio in northeast Tasmania, we've got quite a lot of ground. We're focused mainly on 3 projects at the moment. The Warrentina project, which is here, part of that Lyndhurst-Mangana belt. So we're treating that as an orogenic system. The Beaconsfield project, so we recently acquired the land surrounding the Beaconsfield mine, and there's quite a lot of it. Beaconsfield only have a small footprint in there. So that's very exciting for us, and that'll be on the radar in the near future. And our most progressed project in our portfolio is the Golden Ridge project, which we're treating as an intrusive related gold system, and I'll explain a little bit more on that now. So we're treating it as an intrusive related system, right? Because it's an anomaly around the granite contact. This is a Devonian granite, and it's intruded Mathina sediments. So Devonian granite intruded Ordovician Silurian sediments, and there's like a hornfels around there. And to date we've drilled around 14 holes of diamond at Brilliant, which is this prospect here. We've drilled around 12 RC holes testing some other anomalies along the contact, but they're very widely spaced, and around 19 holes in our Trafalgar prospect there. So mineralisation along the ridge is in auriferous narrow quartz veins with accessory pyrite, arsenopyrite and galena, and trace or minor amounts of pyrrhotite, chalcopyrite and stellarite. They're steeply dipping discrete veins, or they're in stockwork, or they're also in sheeted vein sets. So we see more sheeted vein sets at Brilliant compared to our Trafalgar zone, where it's more discrete. So you can see here, this is, and one important thing to note is the mineralisation is hosted within the granite diorite itself and in the Hornfels contact zone. This is TFD 15. It shows a nice hit we had in the granite, or granite diorite, 0.4 metres at 150 grams a tonne. And you can see bits of gold in there, but one thing I'd like to point out is the alteration that comes with this is sericite alteration, which is quite common in granite diorites, right? Like any hydrothermal fluid might do some kind of sericite alteration, but you get a nice, really distinct green indicator. And you might not see a vein there, but if it's got green stuff, you can look closely and you might see a little arsenopyrite vein or something. It's very handy. And the bottom one here is from TFD 005 at 120 metres downhole. So that was 700 millimetres, or 0.7 of a metre at 152 grams a tonne. And you can see there, that is hosted in the contact aureole. And you can see class of Hornfels Athenaseds, which have been broken up and altered chlorite alteration. But also like chunky sulfides, arsenopyrite and pyrite and galena over here. So gold grades, high gold grades, they're commonly accompanied by 1-to-1 beta silver and high arsenic, which you would expect, and lead. So this is a very useful indicator with soil geochemistry. This is TFD 13, this is close to surface. This at Trafalgar, and it's 0.5 at 170 or 169.8 grams a tonne. So that was 26 metres downhole. And this is a map. We're looking obliquely to the southwest with the soil heat map overlaid. And you can see how the soil heat map kind of picks up all the, where it's, apart from this area here, but where it's in the contact zone, we're seeing the heat. Also highlighting some of our better hits along the zone and rock chips. So we've found 67.1 rock chips at Queen of the Earth, which hasn't seen any drilling, but that's an old mine there. Some of our better RC hits at the link zone is LZ 004, 33 metres at half a gram. So there's still a lot of work to do. We've only tested a small amount, being Trafalgar, Brilliant, and a few RC holes scattered along the contact. So we'll have a closer look at Trafalgar. This is our vein model. We've drilled around 20 holes. We've identified 3 main veins and a number of smaller veins. We've tracked the mineralisation over a length of 400 metres, and that traverses the granite diorite contact. We've done our first round of metallurgical testing and got 94.5% AU recovery, which is pretty good, given that some of those like core photos I just showed you show some pretty chunky sulfides. So just a closer look. I didn't know if you'd be able to see some of those tags. So I blew it up. This is, so we've got the 169 hit up here, TFD 13. That's the closest high-grade hit we've had to surface. Over here, TFD 002. What's that? 4.3 metres at 4.3 grams a tonne with 0.4 at 17 and 0.75 at 10. But that occurs 600 metres downhole. So around 400, 420, 450 metres below surface. So as well as strike continuity, we're also getting a lot of dip continuity in this system. And a footprint of this main Trafalgar zone across strike is around 200 to 300 metres. So recently, we've extended that footprint to 500 metres with the discovery of some high-grade veins outcropping at surface in an old water race that was constructed around 200 metres north of the historic Trafalgar mine. We got rock grabs of almost 100 grams a tonne there, and like 76.6 and 67.1 grams a tonne. So this zone, which we're actively drilling now, significantly increases the Trafalgar footprint. You can just see there with our trenching, we did some trenches and found some of these nice looking veins. This one here graded at 48.8 grams a tonne, around 200 mils wide where we sampled, and that's on surface. This is just a cross section of this new zone, showing our a very rudimentary vein model that we've projected our structural measurements from surface. We're testing with TFD 019. And we've actually kind of pushed that through to test the upper continuation of that TFD 002 very deep hit that I just mentioned before. So that's got a dual purpose there. And then we'll follow up with TFD 20 further to the west along strike. So looking to prove mineralisation is continuous down dip in this area and try and get some strike on that as well, around 80 to 100 metres. Bit of a closer look. So this part on the right is our Trafalgar main vein model. We've recently had another rediscovery where we were looking at some high-res LiDAR data and noticed a mullock heap in front of a adit, and this adit is quite substantial. It's around 130 to 140 metres straight perpendicular into the centre of the ridge, so it provides a great structural exposure to kind of understand what the mineralisation is doing. Anyways, we also, I'll flip to this one. So we found that veins occur in fold hinges and where the bedding dips quite steeply, and surface sampling directly above the adit. We picked up some veins around 7 grams a tonne, and they were in situ, and that projected directly down to where the old timers had put in a small ore drive and extracted some of the ore. And this is the ore drive here, which I mapped in detail. It shows some good grades at the start of the drive. It's around 24 metres long, but they kind of peter out when the lode kind of bifurcates at the end, and that's because there was a kind of lithology change and a very tightly folded fold hinge came into the drive and kind of petered it out. But one thing I didn't mention is we've got a LZRC hole, which is 120 metres along strike of this zone, and that's picking up grades of 3.2 in metre intervals and 4.9. I was going to do a fly through, but we've run out of time. So just to go over some future stuff at Golden Ridge, we're currently doing some field work, and which will probably lead to a trenching campaign at Grenadier, which is the opposite end of the contact from Trafalgar, so around 9 kilometres away. We're focusing on this zone we call the link zone to try and prove mineralisation is continuous along a 2.5 kilometre strike length between our Brilliant prospect and our Trafalgar prospect. These two prospects are our most advanced, so if we can kind of prove that there's mineralisation all along that, we're really progressing the case of this being an economically viable project. And there's still a whole swathe of contact in the north area that we haven't really touched because we've been a bit busy. And then, I've just got some ASX releases if you would like to do some further reading. So thank you.